Hello, everybody. My name is Andy Rivenes. I'm a product manager for Database and Memory. So today what I'd like to do is give you a brief introduction to what Database and Memory is and a little bit about how it works. So the technology behind Database and Memory is kind of like, think of it as being twofold. First, there's the populating the data in the column store and how we operate on that, which we'll talk about here. One of the big advantages is you only have to access the columns that are part of the query, as I mentioned, rather than in a row format where we have to read each row to get to the columns we're interested in. In the column store in columnar format, we can access just the individual columns that we're interested in. We have multiple levels of compression, so we get anywhere from 2x to 20x compression rate. We support something we call in-memory storage indexes, which on individual IMCUs allow us to record min-max values for each of the columns. So now we can actually prune out data if we're scanning and avoid having to look at that data on the fly. So if you have a where clause filter predicate and the data that we're currently scanning doesn't meet that filter predicate, then we can actually skip over that. And then SIMD vector processing, single instruction, multiple data. Think of that as array processing. So rather than, so now we can access data in multiple batches, if you will, in a single instruction, and typically go from being able to scan millions of rows per second per core to billions of rows per second per core. In addition to that, the optimizer understands data that's populated in the column store, and at parse time can decide, do I choose to access that data through the row store, maybe through an index, or do I access it through the column store? So as part of that decision, database or the optimizer can choose to push filter predicates and simple aggregations into the scan of the data. In addition to that, it can change hash joins in the scan and filter operations with the use of Bloom filters. And then we have something else we call in-memory aggregation or vector group by, where we can actually do the group by aggregation during the scan of the data as well. I like to say that the fastest database or the fastest query is one database and memory query is one where you can do all of the processing during the scan of the data and just return the results. So that's like the fastest database and memory query you can have is one where you do all of the filter predicate evaluation, maybe some aggregations, any of the joins and any group bys during the scan of the data. So how do you know which queries will benefit from database and memory? And kind of my rule of thumb is for a non-trivial amount of rows and execution time. In other words, if you're just looking at a few rows, and typically the row store is more efficient. But if you're looking through a lot of data and it's taking a significant amount of time, then if that time is spent either accessing the data, joining the data, or aggregating the data, then database and memory is going to benefit. So let me talk just briefly about what's new. So database and memory was first introduced with the 12.102, the first patch set of 12C, 12.102. We enhanced it significantly in 12.2, 18C, 19C, and then
21C.
Database and memory is an actively developed product. What we've done is we've added additional performance enhancing features, and we're really working hard on making it better or easier to manage the column store. Things like automatic in memory, which is our feature that allows us to automatically populate or evict objects based on usage. And so we're continuing to enhance and make database and memory better. And so we've had lots of features that are available in order to speed up performance and manageability. Does database and memory work with other database features? When running on Exadata, we can take advantage of the flash storage to put our columnar formats there as well. So now you can think of DRAM and flash both being columnar formatted data and having essentially two different tiers of storage. What this can give you is the ability to have very high performance columnar formats, very high performance analytic queries running in DRAM, and then other data still much faster than the row format in the flash cache. And since Exadata has terabytes of flash, you effectively have the ability to have terabytes of columnar formatted data for analytic processing. In addition to that, we can scale out using rack. So if you've run out of memory within a single node, you can extend that to multiple nodes using rack. So now the column store can be as large as you can make or add memory to as many nodes as in your cluster. Scale up for very large memory machines. In addition, we support obviously multi-tenant and different tiers of storage, as I mentioned with Exadata. So no matter where the data is placed, Oracle Database can access that, and for database and memory and DRAM and flash, it can be in columnar format as well. On disk, it could be in row format or HCC format. So we give you the flexibility without having to know where the data is located to be able to have your application run with the most performant data available. In addition to that, since all technologies are supported with Oracle Database, RAC, ASM, RMAN backups, DataGuard, Golden Gate, all of Oracle's existing technology works with database and memory. So you're not limited. You don't have to not be able to use certain technologies that we've added to Oracle Database when using database and memory. So it's fully integrated in Oracle Database. Where can you get more information? So I've gone through this very quickly. There's way more to database and memory. Of course, you really don't have to know all of that, because all you have to do is enable your objects for in-memory and let your applications make use of it. But the devil's in the details, and so you can get more information on our blog website. We have the URL here, DBIM resources page. In addition to that, I've included some links here for the same types of information, the blog, the resources page, where you can get hopefully most of your questions answered. Don't forget the documentation. We have our own in-memory guide in the Oracle documentation, and that can walk you through a lot of the features available. And hopefully you've enjoyed this, and talk to you later.